Okay, so we will start three-phase bridge inverter now. Okay, so now this is three-phase bridge inverter. Actually, you can eliminate these diodes to look the circuit simple. But I have shown the diode. This diagram is from your book PSP Mira. Okay, capacitor is to build up the source voltage. Now the only thing is which you can observe is now single phase inverters are used for low power applications. These three phase inverters are used for high power applications like a three phase induction motor, drives and all. Okay, an inverter generates three phase output. Okay, R, Y, and B. The load can be connected to inverter in star or delta. Okay, dependent on the necessity. Now you can see there are total six devices T1, 1, 2, 3, 4, 5, 6. Forget about the diodes. Six devices. Now you can see that numbering is all odd are on upper half T1, T3, T5. All even are at lower half T4, T6, and T2. Okay. Now just for simplicity, I will tell you that when T1 is conducting, you can see that positive of voltage Vs is connected to the R phase. Here I have shown A. Okay, R phase. When T4 is conducting, then your R phase is connected to negative Vs. Okay, these are some basics. Similarly, when T3 is on, your Y phase is connected to the positive Vs, and when T6 is on, your Y phase is connected to negative Vs. Similarly, when T5 is on, your B phase is connected to positive Vs. When T2 is on, your B phase is connected to negative phase. Okay, now this is the basics. Now listen on the basis of the operations. This three-phase converter has divided, or it has a two types of conduction mode: 180-degree conduction mode and 120-degree conduction mode. Okay, what is the 180 and 120-degree conduction mode? I will let you know. Just a minute. Okay, okay. Here I should have add 180 conduction mode. Okay, 180 conduction. Now, what is 180-degree conduction mode? So in 180-degree conduction mode, one complete cycle. Okay, in 180-degree conduction mode, one complete cycle of waveform. See, this is the waveform, right? So one complete cycle of a 360 is divided into six different intervals. 60, 120, 180, 240, 300, and 360. 1, 2, 3, 4, 5, and 6. Okay, it is divided into six different intervals named as first interval, second interval, third interval, fourth interval, fifth interval, and sixth interval. Okay, now for this particular drive, each interval, okay, in each interval is of a 60-degree, obviously, and in each interval, three devices are conducting at a time. In internal 1, 5, 6, 1 are conducting. In internal 2, 6, 1, 2 are conducting. From 3, you will get a serial number. Here, this is also serial number. But here you can see interval 3, 1, 2, 3 are conducting. Interval 4, 2, 3, 4 are conducting. Interval 5, 3, 4, 5 is conducting. Interval 6, 4, 5, 6 is conducting. 4, 5, 6 means which number? Again, one more thing you can observe here is one thing you can observe it. Here, this is a switch T2. T2 is started conducting from here. When T2 start conducting, after 60-degree, another device will start conducting. T3. After 60-degree, another device will start conducting. After 60-degree, again another device will start conducting. Means each device will get on 60-degree delay to the previous device. Okay, are you getting? So when T1 is conducting, after 60-degree delay, gate pulse will be given to the T2. Okay, after 60-degree delay, gate pulse will be given to the T3. After 60-degree delay, gate pulse will be given to the T4. This is a very important point. Okay, so we'll start from here. Now see, as I said, in first interval, switch 5, 6, 1 are conducting. So what will happen here? switch 5, where is 5? This is 5, this is 6, and this is 1. Here also you can see. This is 5, this is 5, this is 6, and this is 1. So 5, 6, and 1. These three devices are conducting. Okay, now try to understand, it is very important. R phase is connected to plus Vs, Y phase is connected to the minus Vs, and B phase is connected to the plus phase. Okay, if I redraw this waveform, this is for 0 to 60 degree. Yeah? First interval 0 to 60 degree when 5, 6, 1 are closed, means conducting. If I redraw this waveform, okay, see all the impedances of three phases will be same. Okay, so Z, Z, Z or R, whatever. Okay, so if I just eliminate all the circuit and if I take that A point over here, B point directly here at lower side and C point at upper side. See, A point upper side, okay, C point also upper side, and B point is at a through 6 lower side. B point lower side, C point upper side, A point upper side. I will get circuit like this. Okay. Now see Z and Z are in a parallel. Okay, and another Z is in a series. Okay. If I want to find out the phase voltage, okay, first I will need its current. So current multiplied by resistance will be voltage. So see Z and Z. So total impedance is a Z by 2. Are you getting? Z and Z in parallel, impedance is Z by 2. So Z by 2 plus Z, because that is in a series. Z by 2 plus Z. Okay, Z by 2 plus Z, so it will become 3Z by 2. It will become 3Z by 2 for this. Okay, so one thing remember, what is the current flowing, main current I1? I1 is voltage divided by resistance. Voltage is a Vs. Vs divided by this resistance, which is what? 3Z by 2. Okay, so 2 will go on upper side. Uh, just a second. I will take a word file to explain. Okay. This is the circuit. Now you can see what is impedance Z by 2 plus Z. Okay. It is Z by 2 plus Z. Okay. So it will become 2Z plus 1Z. So 3Z by 2. So 3Z by 2. This is the total impedance. Okay. 3Z by 2. Now what is the current flowing? Current equal to Vs divided by this impedance. So where it is? I will take this side. Take another equation separately. So now what is the equation? Voltage, that is Vs. Here also Vs, sorry, Vs divided by voltage divided by total current. Sorry, voltage divided by total impedance is total current. What is total impedance? 3Z by 2. Okay, so when I will write 3Z by 2 over here, 2 will go on upper side. So it will become 2 Vs by 3Z. Okay, so 2 Vs by 3Z. This is the total current. Okay, I1. Okay. Now when someone will ask me what is the what I can say voltage at particular this phase voltage VA0 means VRO or VRYB VBO. What is the voltage VRO or VBO? So voltage will be